In this screencast, we're going to look at finding the determinants of a matrix, the determinant of a matrix via row reduction. This process is best on large matrices, and it's actually the algorithm used inside computers. We'll illustrate on a 3x3 to show what's happening, just to save a little bit of time, but the idea is this could be used on some ginormous matrix. You can make it as big as you want, 30 by 30 or something, in which using the cofactor expansion is a bad idea. As we go, we're going to keep track of each of our steps. So let's just start by row reducing the matrix, and we're going to row reduce to an upper triangular matrix. In other words, we're just going to make the lower left 0. So first, we need to swap some rows. So we'll take row 1 and interchange it with row 2, which gives us -2, 2, 1, 0, -3, 4, 5, -2, 1. The next step is I want to use this 2 to get rid of the 5. I don't really want to divide by 2. That's going to introduce fractions. So instead, let's double this. So let's take 2 times row 3. And it might be tempting to say, well, let's add that to 5 row 1. But this is now 2 row operations. We're doubling a row, and then we're adding a multiple of a row to another. So we're only going to do 1 row operation at a time. As we do this first row, or the first one, the 2R3, that gives us -2, 2, 1, 0, -3, 4, 5, -2, 1. Oh, I got to double them. 10, -4, 2. All right, now I can take row 3 and add 5 times row 1, which gives me -2, 2, 1, 0, -3, 4. And now that one plus 5 of those is 0. That one plus 5 of those is 6. And that one plus 5 of those looks like a 7. All right, before we keep going, I just want to remind us, in the last screencast we talked about elementary matrices. Row reducing, each row operation is the same as multiplying by an elementary matrix. I'm going to write down this first one. We swapped 2 rows, 0, 1, 1, 0, 0, 0, 1, 0, 0. All right, we just swapped row 1 and row 2. In this one, we took row 3 and times it by 2. So our second matrix is 1. We just times row 3 by 2. So here's the elementary matrix. Every single time we go, we have an E3, which is, now we're taking row 3 plus 5 row 1, so I'll put a 5 there. And each time we go, we're just multiplying by an elementary matrix. So now we keep on going. I'd like now to make the 6 disappear. Well, that's just row 3 plus 2 times row 2. And we get a -2, 2, 1, 0, -3, 4, 0, 0. And that one plus 2 of those makes that 15. Okay, this is now upper triangular. The last elementary matrix we had, I'll call it E4, was let's take row 3 and add 2 of row 2. All right. What this means, if I call this U, is if I start with matrix A and multiply on the left by E1, I get that matrix. So if I take A and multiply on the left by E1, that gets me this matrix. If I multiply by E2 on the left, that gets me this matrix. If I multiply by E3 on the left, it gets me that matrix. And if I multiply by E4 on the left, it provides me with U. Well, now I know how I can take A and row reduce it to U using multiplication. So now we're going to take determinants. The nice thing about the determinant is you can break it up as a product of determinants. And we already know how to find the determinants of elementary matrices. The determinant of this first matrix where we flopped 2 rows is -1. The determinant of this matrix where we doubled the third row was 2. The determinant, whenever you add a multiple of a row to another, doesn't change anything because you just take the product of the diagonals, which is 1. And the determinant of this matrix, again, is just 1. So currently, the only thing left is the determinant of U, which we know is -2 times -3. It's just the product of the diagonals, times 15. The only number unknown in here is the determinant of a, so I can solve for it. The determinant of a is, we got the -2, the -3, the 15, divide by the 2, and the -1, and that takes care of all those, and we have a -45. Row reduction tells us precisely how to take A and multiply by elementary matrices to get an upper triangular. Determinants of upper triangulars are simple. So, if I can keep track of the row operations, the elementary matrices, and then take their determinants, I just stick those in the denominator, and out pops the determinant of A. You can use this on any size matrix, just keep track of each row operation, and that's all. That completes the screencast.